Hi there. So today we are going to solve the LeetCode problem number 301, that is remove minimum invalid parentheses. There are different approaches to solve this problem, but today we are going to solve this problem via the first approach, that is backtracking. So the prerequisite will be DFS. Our goal is to make the expression valid by removing the minimum number of parentheses. It means that we are given an invalid expression with invalid or misplaced parentheses. We are required to remove minimum number of the parentheses to make it valid. Let us move to the next page so that we can further understand the agenda of today's problem. So the agenda of today's problem is, first of all, we'll discover what is the problem with the help of examples. Then we'll discover where does this problem occur in real life. And after that, we'll take a look at why this problem should be solved. And after that, we will check how to solve this problem via the dry running of a particular problem. And at the end, we'll look at the solution, that is the code. First of all, what is the problem? Just like the numerical examples in the physics, we are provided here with some pre conditions, and something is required of us. First of all, we are given a string that contains open and close parentheses as well as some letters. It is already told to us that some parentheses may be misplaced. That's why our expression is invalid expression. Our task is to remove the minimum number of parentheses to make it valid parentheses. So at the end, we have to return all possible valid expressions that can be formed from this invalid expression. For example, here in this example, let us further understand this example on the next page. As you can see here, we have two ways to make this invalid expression into a valid one. First way is we can either remove the first and the third index so that we'll get a final valid expression at the end. And the second way is we could remove second and the third index, and the final valid expression will be obtained. Now look at this second example. Here our invalid expression is provided on the left side, and the valid expression obtained out of this invalid expression are provided at the right side. First way to create a valid expression out of this invalid expression is to remove the first index. So we'll get a final valid expression. As you guys know that more than one valid expressions can be obtained out of out of an invalid expression. The second way is to remove the third index, and we'll get a second valid expression. The third way is to remove the fourth index, and we'll get a final repeated valid expression that is obtained while removing the third index. Now this example 3 is provided on the LeetCode platform of this very problem at the editorial tab. Now here our invalid expression is provided at the top. The yellow background box is representing those parentheses which are to be removed. So you guys can see that there are three ways by which we can obtain solution 1, that is a valid expression. First way is to remove zeroth and first index. Second way is to remove second and third index. Third way is remove zeroth and third index. Now the second solution, which is also a valid expression, as you guys can see that the first solution and second solution both are different from one another. So the second solution here can be obtained via three different ways. First way is to remove zeroth and fifth index. Second way is to remove first and fifth index. Third way is to remove third and fifth index. Now Let us take a look at where this problem occur in the real life. As you guys know that our code compilers and interpreters are always validating the brackets so that they could uh, tell you where is the syntax error. Same is the case with the expression parsing in the calculators, and the form validation also uh, uh, is also working on the same principle. Whenever you are providing certain input in a field, if that is regarding a code, that form validation is also working on the same principle. But the best of all the real world scenarios is the text editor or the IDE, where the IDE is looking at the syntax checking for developers. As you guys can see here at the bottom, the Visual Studio Code is highlighting an error in the form of a red bracket or the red parenthesis at the left side, and is showing no error at the right side, which makes this easy for the developers to take a quick look at the parenthesis misplacing. Now, this was the real world scenario. Now, why this problem should be solved? At first, I will start from the last point. This problem should be solved because this builds the foundation for recursion and backtracking. Since here our approach one is going to tackle this problem with help of backtracking. The second thing I want to share with you is this helps in error detection and autocorrection. These 2 points are enough here for telling a person why this problem should be solved. Now, how to solve this problem? We have to try all the possibilities of removing or keeping a parenthesis. Since this is a DFS approach or the backtracking approach here, so we are going to try or explore all the possibilities. Now here, the invalid expression can either contain open parenthesis, close parenthesis, or a letter. That could be any letter from the alphabets. The second point says we have to keep track of the number of the left parenthesis, that is open parenthesis, and the number of the right parenthesis, that is close parenthesis. And the rem count here is actually pointing to the removal of the parenthesis. That means how many parentheses have been removed from the provided invalid expression. For example, if we are provided with an invalid expression whose length is 5, as you guys can know, we can create a valid expression out of it by removing a single parenthesis. But at the same time, we can also create a valid expression out of it by removing two parentheses. But our goal is to get that valid expression in which minimum number of parentheses have been removed. So therefore, we'll keep track of the parenthesis removal with the help of rem count. We'll only accept expressions that we will only accept the valid expression if they meet this condition. That is, if the number of the left parenthesis is equal to the number of the right parenthesis. And finally, we'll optimize this with the help of pruning. Now, let us move forward so that we can understand how pruning will occur. As you guys know that here the intuition is backtracking. So at first, for each character in the invalid expression, if it is not a parenthesis, neither open nor close, it means it's a character. So if it is a character, our only option is we have to keep it. But if it is not a character, it's an open or a close parenthesis, we have either to keep it or to remove it. And here the second point says we have to explore all the possibilities, since this is going to be a backtracking, or we can say a DFS problem. What does explore mean? Explore mean if it's a character, so it will have just one option, that is keep it. So we'll have to keep it. But if it is a parenthesis, either open or closed, we have two options. So we have to explore both options. We have to keep it as well as remove it, which means whenever we get a parenthesis, first of all, we will remove it or ignore it and check whether we are getting a valid expression or not. If we are not getting a valid expression, then we will move back, that is backtracking, and then we will keep it. And after keeping it, we will check either keeping it makes a good impact on getting a valid expression or not. Now here, as you guys know, the term explore is referring to exploring a map or such kind of things. So here, just the key explore is giving a semantic of the graph problems. We are here to use out of these two, BFS or DFS. But here, as you guys know, we are using backtracking, so we are going to use DFS. Now let us take a good example and perform dry running on it. Here, the problem is provided at the top left corner and the conditions of different things are provided at the top right corner. First of all, we have to understand what is a branch and leaf. But before understanding both these things, we have to understand what is an invalid expression and what is a valid expression. An invalid expression will be such an expression in which number of close parentheses are greater than the number of the open parentheses. And a valid expression is such an expression in which number of clause expression is less than or equal to number of open parentheses. I'm not talking about the whole expression. I'm talking about here the branch. I'm talking about this tree. When we are going to say that this specific expression we have is a valid or invalid while traversing through the tree. And you guys will know when we start our traversal. What is a branch? A branch is such an index or such a part or character of the invalid expression where we are getting a valid expression and string is not parsed. And a leaf is such an index or such a character of the invalid expression where our expression generated is invalid or our string is completely parsed. So let us try run. First of all, we will take our pointer to the index 0. And if we know, you guys know, if we ignore this parenthesis, we'll get expression empty. And you guys know empty expression is a valid expression. So this is a branch and string is still not parsed. Now we'll move our pointer to the first index. Here, now we have two choices, either to ignore it or to keep it. Let us ignore it again. And we'll get the same expression, that is empty expression, which is valid. Why? Because number of open parentheses and close parentheses, neither of them are greater than one another, and our expression, our string is still not parsed, therefore it is a branch. Now let us move to the second index. Here we have two options, either to keep it or to ignore it. And now let us consider we ignore it. If we ignore it, we are getting a final valid expression, that is empty expression, and it is a leaf. Why? Because string has been completely parsed. Now let us consider that we are keeping this index, second index. So if we keep this index, we'll get an expression that is an invalid expression in according to the prior condition provided at the top right corner. Now if we move our pointer back to the first index, we will know that we have already passed through the ignoring state. Now we are going to keep this parenthesis. After keeping it, we will get an invalid expression, that is a leaf. So we will leave it and move our pointer back to the 0th index. Once we are at the 0th index, now we know that we have already ignored it. As you guys also know that we have already ignored it. Now we are going to keep it. If we keep it, this is a valid expression at this moment. Why? Because still our string has not completely been passed. This means that this can be a branch. Now we will move our pointer to the first index. We can either ignore it or keep it. If we ignore it, then we'll get a valid expression, that is the prior expression, open parentheses. we know that this is still a branch because our string has not been completely parsed. Now we move our pointer to the second index. Here we have two choices, either to ignore it or to keep it. First we ignore it and we'll get an invalid expression because here the number of the close parentheses are less than the number of the open parentheses, because at the end the only way to tell either this expression is valid or not is the number of the open and close parentheses must be same, and this is a leaf. Now let us consider instead of ignoring it we keep it. We'll get a valid expression. Now we have to traverse throughout the tree, so our pointer will move back to the first index and we are going to keep it. As you guys know, we have already ignored it. If we keep it, we'll get a valid expression here. So after this, we'll move our pointer to the second index. We have two choices, either to ignore it or to keep it. If we ignore it, we'll get a final valid expression. And if we keep it, we'll get an invalid expression. Here the final parenthesis provided in the expression is wrong as provided at the top left corner. You can see second index. So this is just a mistake. Now as you guys know, we have traversed throughout the tree. Now we have these final leaves where invalid and valid parentheses are provided. We are going to remove the invalid ones and we'll take out the valid ones. Since you guys know that these are repeating one another, so we are going to put them into a set. After putting them into a set, let us ask ourselves what was required of us. We were required to return expression with a minimal removal. But here you guys know that the first answer has removal of three parentheses. Second one has removal of just one parenthesis. So here we can say that our final answer is going to the second one, that is this one. So how to solve this problem? Actually, we will also track number of the removals and keep adding that expression in valid expression set which has minimum removal. So now take a look at the code. First of all, we will create a function that is remove invalid parenthesis function, and here we will call a reset function. Why this function is called? Actually, this function is taking care of the class level variables. We have created two class level variables, valid expression and minimum remove. This minimum remove is keeping track of the minimum global minima, that is minimum number of the parentheses removed to get the final answer. The reset function is always setting them to a specific initialized value. What is it helping in? It is helping in performing all the test cases so that whenever a new test case run, our both the class level variables are empty or they are initialized with the new values so that the program does not use the prior values. Now after this, in our actual function, that is remove invalid parenthesis function, we are calling a remaining function. What does this remaining function takes and what is it doing with all those things which we are providing it? First of all, we are providing it a string that is the original invalid expression, the index from which we are going to start, either to keep it or to leave it. The left the left count is actually keeping track of the left parenthesis, right count is keeping track of the right parenthesis. Expr is the current expression that has been created till now, and rem count is keeping track of the minimum removal of the parenthesis in getting this very expression that is in this remaining function, not the provided invalid expression. Now, first of all, entering into this function, we'll check does our expression has been completely passed or not. If it is completely passed, that means our index is equal to the length of the string. We will check is the parenthesis or the is the expression currently created is a valid one or not. If it is a valid one, then it means the left count is equal to right count. After that, we'll check the minimum removal made in getting this very expression expr is less than or equal to the global minima. If it is less than, then we will put that into a variable that is possible answer. Since you guys know that was a list, that therefore we used the function join. Now after that, if the removal count is less than the global minima, we are going to reset the global minima, and the valid expressions is reinitialized to a empty set, and we are going to add that possible answer into the our valid expressions list, our valid expression set. After that, we have an else condition. This else condition is pointing to the condition where we have not still completely parsed the string. If we have not completely parsed the invalid expression, we are going to take the current index, the current character. If the current character is not an a parenthesis, that means it's an alphabet. We have only one choice. We are going to keep it. After keeping it, we are going to recall this function and providing the same invalid expression with the increment in the index, as this was an alphabet. Left count same, right count same. The expression generated will be the same, and the removal count will be the same because we have not removed anything. After this, we could have we have to pop it out because we have to perform the backtracking as well. Now, in the else condition, if we have open or the close parenthesis, first we are going to ignore it. And here, when we ignore it, we are going to increment the index, which means we are moving to the next character. And we are also incrementing the removal count, as you guys can know, at the last parameter at the statement number 52, that is self dot remaining. The last parameter is rem count plus 1. Once we have ignored it, if the ignoring gives a particular specific right answer, valid expression, then you guys can see at the line number 39, we will add that answer into the valid expression. But if we are not getting a valid expression, then we will come back here and we are going to keep it, because in ignoring that parenthesis didn't give ourselves a valid expression, so we are going to keep it. When we keep it, we are going to check either it is an open parenthesis or a close parenthesis. If it is an open parenthesis, we are going to increment the index by 1, left count by 1. But if it is a right parenthesis, we are going to keep it in a way such that we are going to first check either our right count is less than the left count or not. If it is less than, then we are going to keep it, and if it is equal to left count or greater than, then we are not going to keep it, because it will make a disturbance in our expression, in our valid expression. And since you guys know, for backtracking, we'll also pop this out at the end, and this was the main function in which we called remaining. After this, our class level variable valid expression will have a final list of the valid expressions, a set actually. We will put that into the constructor of list, and the final thing we'll get will be a list. Now for personal practice, this is the problem you can take a look at. And thank you thanks a lot to all of you for taking this lecture here, and do not forget to subscribe.